AEC Tech Talks is all about technical topics related to architecture, civil engineering, and construction. We try to spread the knowledge and create awareness. I'm your host, Anisha Agrawal. I'm a structural engineer and I hold a master's degree in structural engineering from the University of Michigan, Ann Arbor. And at present, I'm working from India and serving domestic and international clients. With me is my co-host, Gaurav Agrawal. Gaurav, would you like to introduce yourself?
Sure. Thank you, Anisha. So my name is Gaurav. I am the owner of Agrawal Structural Consultants. We primarily focus on structural design of residential and commercial projects in India and all over the world. Same as Anisha, I have a master's degree in structural engineering.
Our guest for today is Harsh Patel. Harsh holds a master's and is working in Virginia with RDM International. And our topic for today is really interesting. It is the base of payment design, and we'll also touch on some software and some resources that can help you in the design. So, Harsh, over to you.
So before Harsh takes on, I'll just like to congratulate Harsh for recently getting his PE license. So that's a big accomplishment. So congratulations to you, Harsh.
Thank you, Gaurav. First of all, thank you, Gaurav and Anisha, for inviting me to this platform. And good evening to everyone, all our listeners in India, and good morning, good afternoon from my side because it's afternoon, noon here. So, yes, as they mentioned, I am a payment engineering practitioner based out of Virginia, and I chose this path after bachelor's because I had a predilection towards civil engineering right from the start. Excited for this chat.
Great.
I'll first start by showing this video to everyone. I will pause the video here and give you and tell you what is payment engineering all about and what is going on here. You see, a pavement engineering is basically a very big jigsaw puzzle. Okay, you have materials in the form of aggregates, and you have to mix them together, bound them with a sticky thing so that they don't move, and you have to put them in place. Well, this that sticky thing can be two types of sticky things: asphalt or concrete or cement. So you get concrete. So I all the three have to go together hand in hand in a perfect way to get a road like we see in USA and not as we're seeing right now. So example here we see that the aggregate is coming out easily. That is because the bonding is not properly done of the materials with the aggregates. Also, it is quite easy to see that the layer is very thin, which might not be adequate for the amount of vehicular load is going to be put on this kind of surface. So my job and my field is all about making sure that the rider never feels any discomfort, even know that there is a road beneath it. It should be that noiseless, that smooth, and that seamless. And the challenges, well, one of the biggest challenge is this one of the biggest planes you see. This is a A380, and this can weigh up to 10,000 pounds. For my SI unit friends, 10,000 pounds is that's 453 metric tons. When such amount of weight is falling on the runway, is landing on the runway, you have to make sure that this does not happen. Well, if this happens, or even a slight amount of particles come out, which are called flying foreign object debris (FOD), it damage the plane. And if it damages the plane, the airlines usually they will sue the airport, and that will cost millions. So these multi-million dollar vehicles need to be working on perfect condition and working and proper runways, and that's what our job is all about, to make sure that these things go as planned.
Just to quickly ask, even in the US, are runways made of asphalt or do is concrete preferred material?
That is a good question, Gaurav. So in USA, you can find uh, airport runways or taxiways or aprons. They can be asphalt. They can be concrete. Asphalt is cheaper as a rule of thumb. Well, this is really all about design. So for going into specifics, we have to perform all the analysis. But as a rule of thumb, asphalt is usually cheaper than the PCC or the Portland cement concrete, and concrete is more durable than asphalt. So, as most things in life, it usually falls into how much money the client is thinking of putting into this. So, for example, this is, you can see, asphalt. Oh, sorry, PCC. This is all concrete. To answer your question, Gaurav, we have both in here in USA. We have both kind of airports, and it depends on the project what kind of airport we have to design.
Does it also depend on the weather conditions, whether we choose asphalt or concrete?
Yes. So if you, I'm sorry. So the weather conditions are usually taken care of in both of the asphalt and Portland cement concrete runways, taxiways, and aprons, because the biggest challenge to any kind of road, any kind of pavement is water.
Hmm.
Water, when it seeps through, it breaks the bonds between the aggregates. It breaks the interlock. You create the gap.
Hmm.
It starts moving. Pavement starts moving. It goes wider, wider. The gap widens. You get potholes. So biggest challenge, one of the biggest challenges is water. Water can be rain from up. Water can be from thaw, like those water freezes, and it is coming seeping up from below. That is also a problem. So it can be coming from both up and down. So in places like Alaska or like North Dakota or South Dakota, you have those kind of like cold climate condition problems. And in places like Florida or heavy rain areas, you have the drainage problems.
Hmm.
Let's detour here and just talk about a recent phenomenon which has happened. Guys might be aware, right? So Dubai, yes. So Dubai airport was completely shut down because of that cloud seeding experiment or some weather condition problem. So these airports, of course, when we are engineering these systems, we are given the climatic conditions, and suddenly, if like a rare event happens, this is what you get. Drainage is properly taken care of in all of our designs. You will Dubai is in a desert, and this would not have been probably engineered. So you saw this problem.
So you are saying that whether it is snow or like the area has snow or it has conditions like in Florida, you choose a material accordingly, or like both materials can be used in both conditions. Is that what you're saying?
Yes, there is a so we follow the FAA, Federal Aviation Authority guidelines to do our work. For our viewers here, just type FAA10H and press this link. You will get this document, standard specifications for construction of airports. This is all what it is about. In this takes care of all the kind of construction climates, materials, and what engineer needs to take care of. So Anisha, coming back to your question, yes, there is this requirement set up by the specification. The contractors have to adhere to it. If they don't adhere to it, we simply ask them to resubmit their materials or their submittal, as it is called here. Mind you that this specification is tailored for each of the client requirements. So as we were discussing, a Las Vegas specification, airport specification will be quite different from an Alaskan airport specification, and that will be quite different from a Florida airport specification. All this is again tied back to the client requirements and needs.
Understood. It's more like just like the building codes. They are different for each state. So likewise, you have same for pavement codes. I'm understanding.
So the code is same. The
Uh-huh.
code is the same FA10H. It is edited. It is the construction documents contains an edited version of this.
Mm-hmm.
Tracked changes. So the client knows that what changes were made to the original 10H spec.
Mm-hmm. Understood.
Yeah, it's like in buildings you have ACI code and all the local cities have their
Correct.
local codes or the zoning codes.
Mm-hmm.
Okay.
And and the one statement is common in that is use go to ACI. So
Or IBC.
There is no just local code here, but yes, instead of that statement, that's the whole spec.
yeah, got it. Just thinking that you said that it depend on the client. I get that, of course, but are there any structural or geotechnical parameters affecting the decision between asphalt or a concrete pavement? Because in my understanding, I think concrete pavement would be better because there won't be any spalling of asphalt or poor work. So
No,
are there
that is yes, that is quite a common misconception. So I will take this opportunity to explain myself better. So go to your Google tab and type the far field software, and you will get this link. You can download the software, it's free of cost. When you use this software, I have already on my computer, you will see that you can design the pavement based on your based on the traffic kind of aircraft you have and the kind of materials you want to make it with. So you can make a new flexible pavement, so which would be a AC pavement over 209 aggregate over subgrade. So basically, this is a common thing that no asphalt or PCC pavement, they are not directly put. Usually, they are not directly put for a new pavement over a subgrade. There is a base material, and over base material, the surface material is put. So be it a rigid pavement, pavement means the concrete pavement or an asphalt pavement. It's just about thickness, Gaurav. Just the
okay?
thickness of this might increase to, I don't know, 10 inches, or like if the heavy aircrafts are here, or like 15 inches, or
Yeah,
like you would be get like if you do a new rigid pavement, you might get a 19-inch pavement, or you
okay.
might get a 18-inch pavement. This is all calculated by the software. The software calculates it based on the traffic mixes there, and the traffic mix is like most updated right here based on the most common aircrafts used in this commercial industry. Again, coming back to your point, Gaurav, both of the materials can do the job. It's just about thickness and how much material you are gonna put.
Since we're talking about it, can we also tell our viewers the difference between flexible and rigid pavement?
For sure. So the AC pavement is basically your hot mix asphalt. Basically, it's called HMA. What is underneath it? Same goes for rigid. Wow, my R is okay. So this would be your PCC, and this would be your base, and this would be your subgrade. Again, to reiterate, either a rigid or a flexible pavement can be constructed on either. It's just based on the project requirements and the geographical conditions and other things considered to make a decision among both. And that's yeah, and that is also a thing which changes with time. That maybe right now it's a flexible payment that might be changed into a rigid payment system.
Okay.
So yeah, this is a good image to put my point forth.
Okay. So what is the life of an average runway pavement?
we design it for the design life of 20 years.
20 years.
But yeah, so the design life, while the our computations is 20 years, assuming that the proper maintenance, adequate care has been taken throughout the life.
And what are
Uh,
some of the loads that you take into consideration?
So most of the loads, like talking in the airport airport example, it's from the aircrafts. And okay, so Anisha brings up a good point. So I will take this opportunity to tell you that basically there are two types of airports. One is your commercial airport, which is your IGI, or like your IGIs, or the Mumbai International Airport, like which has both the cargo flights. You know, the UPS. I mean, example here it is UPS, USPS. I
yeah,
think
yeah,
in India it's DHL, right, Gaurav? Anisha,
yeah.
DHL
DHL
is
and
there.
Blue Dart.
Blue Dart for that.
Yes, yes. Other kind of airport is called general aviation airport, which are very common, which are pretty standard here. So general aviation airports are smaller airports. They are like they service these small aircrafts that
The
like
charter plane.
chartered planes. Yes, correct. Chartered planes. Now, as you can see from the photos, these airplanes are really small. Like they don't have that much weight. It's like 4,000 pounds, 5,000 pounds weight we are talking about, and their axles are also uh, not too complex. So if I choose to go to the general aviation tab in the software and I click like a PA-32, this is a type of airplane. See, you see the drastic change, right? It is just 3,400 pounds
Yeah.
and just a single axle, just two wheels
Mhm.
compared to this. So coming back to like 1 million pounds and this gear configuration. So coming back to Anisha's point, like the weights are very different for commercial airports, so their design will be more robust, thicker, and accordingly we choose the loads for these. So yeah, so it depends again on. So before we start before we start our project, we are given what is called a traffic fleet mix. Traffic fleet mix is basically type of airplane, A220 for example, and what are the annual departures. This is given to us by the client.
Okay.
This tab and this tab.
Hmm.
And using this, we know, okay, so this is the traffic we have, and we have to design for this.
Okay. So basically, they're telling us what airplanes will be using that runway, right?
Yes.
Right. And then based on okay, we have these many planes, and this is the loading. Now, based on that, how do you decide like design the runway? Do you take the worst case?
Yes. So in this, we do like a 20-year design, as I told.
Hmm.
And when we are doing the 20-year design, we basically incorporate our worst case by putting a 2% annual growth. And you again, this can be depending on the project. Usually this is true because this is how the FAA is governing this. So the software, not the software, the code which I showed you, right, the
Hmm.
10H.
Yeah.
Yeah.
So that code has all the discussion about this. So usually you can incorporate that worst case scenario by increasing the annual growth. So basically annual growth is how much this annual departure will grow over the 20 years.
Hmm.
And that's a worst case scenario.
Okay.
So even if we have the current departures, we are designing it for the future traffic. So it is more robust.
Okay. And then like I'm seeing this column which has the tire pressure, and then on the
Yes.
right. And so I'm assuming that you're using this to compare somehow with the CBR that you mentioned earlier.
So CBR is already given to us by the geotechnical exploration for this project. So a
Hmm.
geotech report is given to us, so we know how much is the CBR. So this is done to calculate how much like how much force is being, like how much load is applied on the pavement and how much thickness will be able to bear the load of the pavement. So this is all given to already pre-filled, because this is given by the manufacturer, Airbus, Boeing, or the manufacturer of the airplane.
Okay.
So this is all already given to us. We just use this information to calculate the correct thickness of this.
Okay. Okay. So where is the result page for this software?
So result page, if you like, for example, run this thickness design. So you go to the Explorer tab and you go Structure Report. So you get, okay, 15" and over 5 over 6. So yeah, so it is designed for 20 years.
15. Okay, so you said it is should be 15 inches thick, right? Because your first case says that thickness required is 15.
So like, let me change it to 4. And again, this is just a test example, so this is not a good. So let me, okay, to make things easy, I choose new flexible. This is the default setting, okay? Nothing is tampered with. And I press run. And it comes up with something. So you get this, we are calculating how much base is to put there, because the top of the surface is same. 4 inch of surface over 5 inch, that is constant. We are just checking how much base we have to put. Now again, we cannot just blindly use this and say, okay, we need this much amount of pavement. So this needs to be again studied along with the design parameters, client requirements, what are they looking for, and we keep on redefining and come up with the best case scenario, which is like robust over the design life.
Oh, okay.
You can just scroll down. So what I'm trying to do is trying to read these results. I mean, because like it's not just enough to see the results. In my opinion, when we design anything in softwares, we have to process the results because every information is not given. So Harsh, if you are just given, if you have to do a quick check, if suppose a junior engineer does the design and you are asked to check, and if you only have this results, how would you go on about and check if he has put the proper inputs or not, or if everything is going on correctly or not?
Oh, that is a good question, Gaurav. So first of all, what I would check is I will see which is the heaviest aircraft again, because the heaviest, whatever is the heaviest, even in a structure design, that will cause the problem.
Yeah.
So good rule of thumb is to see that this is called a CDF contribution, which is cumulative damage factor. So the damage done, this is actually calculating the damage done to the pavement, this software. And that is why I was saying we should not blindly depend on the machine. So this is calculating the CDF, and I have to see, okay, the software tells me the A306 it will do the most amount of contribution. So this should all add up to 1. First of all, that is my first check, because 1 is like the maximum amount of damage. This is like a percentage. So 67% of the damage is done by this, and 30% is done by this, and like so on. So I know, okay, like this tells me that this is a robust design, because it is taking care of the, like, this should be less than 1. If any one of this is higher than 1, we are in a problem.
Okay.
So this is one check. Second check is to see if they have chosen the modulus properly. So
Yeah.
what is modulus basically? So elastic modular is basically how, like, is a representation, one of the parameters to check how what is the pavement strength in layman terms, without going too technical. So this is determined using a machine we use, which is called heavyweight deflectometer. So what basically is happening is they drop a load, they get the deflections from this. There are 9 sensors which are provided across this, and the farther you go, the lowest deflections you have. So we calculate the elastic modulus of this of all the layers underneath it using this machine, which is input in our analysis. I think
So basically, they do stress over strain, right? To get the elastic modulus.
we are putting like a we are dropping very heavy load on the pavement, and we are calculating the deflections which the pavement give. So we input that the modulus we have calculated into this modulus, and then we can see the structure report. So coming back to Gaurav's question, I am checking the modulus, how he has calculated using the non-deflection testing data we have, and then I'm checking if the aircraft CDF information is correct or not.
Yeah, I think it is stress versus strain only, Anisha. I think I remember doing this kind of experiments in college
Yeah, same.
and laboratories. You calculate deflection, and based on that, I think because you are dropping in load. So yeah.
Okay.
So I have one more question. So this, what we have discussed is about what's going on in the outer of the pavement. Now let's go into the inside of the pavement. I mean, there must be steel, right? Rebar must be there. So and you have the limit of pouring concrete in a specific area, and then you must connect those two like pavement sets, right? So how do you connect them? Like, what are your
So,
typical materials?
so that is a good question, and it will lead you guys to know that there is no bars in the
Okay,
pavement design. There is no reinforcement bars. There are double bars.
okay,
So there is no RCC. There is no reinforced cement concrete. It is PCC, plain cement
okay,
concrete. That's why
okay,
we call it. That's why we call it PCC pavement.
Mhm.
So
okay,
yes. So double bar. So basically, okay, this is first of all, you might have already know that if you are constructing a flexible pavement, you don't need a double bar
Yeah.
because
yeah,
it
yeah,
is continuously laid down. So
yes,
this is all about concrete pavement. So concrete pavement, you have to connect the bars to the panels, because they are done usually like in a 20 by 15, 20 by 20, 25 by 25 feet slabs, we call it. And if the load is put on one slab, you need for it to be effectively transferred to the other slab. So because if big airplane like A380 or Boeing 777 going on a runway or taxiway, you don't want it to just put all the load on one of the section or one of the joint lines. Like, you want it to be uniformly distributed as much as possible across the whole pavement surface. That is achieved through dowel bars. So as you can see here that the dowel bars here do a good job if placed properly and according to the code. Again, again and again will keep coming back to the code. That code is the same code, 10H. All the information is available here, which is freely available on this website. So you can go through the dowel bar, how it should be provided, and what kind of material should be there, how it should be installed, and all those things. If achieved properly, you get 100% effective load transfer, and your pavement is in good shape for the design life of 20 years.
So how does this joint also act as an expansion joint?
Yes, we do have expansion joints.
So this does not act as an expansion joint. That is different.
So yes, that is different. Yes,
Okay. Can you share some more information on that as well?
expansion joints.
Yeah, for runway especially.
Yeah, I'm not good at drawing. That's why I'm taking help of expansion joints. Sorry, the Google images.
oh,
So I'm not getting a good picture of expansion joints, but yes, like just to put like if you put the dowel bars are put in a transverse section, so the it is put perpendicular to the length of the pavement because you want it to effectively transfer the load across the section. So it will
Yeah.
not be put like this, it will be put like this. So that is how the load transfer is achieved in here.
So, I mean, just as a structural engineer, we always learn that joints are the weakest link of any a structure, any load path, and most of the people make errors while designing the joints, and it's always challenging. So, Harsh, have you faced any challenges designing these dowels, or have you faced any challenge related to these dowels in any of your project?
Not so honestly, most of our challenge is on the thickness of the design and the
Okay.
geometrical alignment. In our practice, dowel bars is not that big of a challenge because as in USA, I'm saying. I mean, I'm
Yeah.
not sure about here. Like, pardon my ignorance in that field. In USA, most of the time, contractors do a really good job of dowel bar placement. The biggest challenge we have is materials and the compaction. The field compaction of the material is really important because again it's like a very big jigsaw puzzle, and you have to make sure that the materials are really bound into each other properly so that you don't have like that gentleman was showing us removing the road from his hands. And also in like a small scale also, like those small aggregates popping out and spalls, as Gaurav mentioned, like the workmanship has to be proper. As designers, I can make sure that I can give you the best materials you have to use, like if it's proper or not. I will tell you the thickness of each surface layer, base layer, for the amount, for the subgrade CBR provided to us, the climatic conditions given to us, and we will make sure that the like usually we have this called construction management (CM), and like again this is a very project specific thing, and without going too much into details, like usually the airport asks companies like us to provide us with a personnel to oversee if the contractor is doing the job properly or not. So
Yeah.
we are like from the owner side, we are seeing if the work is done properly or not. We like the our companies like us, we give a FOR, field observation report, every night. As Anisha was asking about, like even double bar placements or the light cans inside the pavement. You might have noticed that there is no street light
Yeah.
in
Yeah.
the runway pavement.
Yeah.
It is all inside. So that is another like whole world of knowledge. Like I am not qualified on that. It is an electrical engineering job. So that also is like I was amazed to see uh, how complex a uh, seemingly simple thing can be. And as Gaurav rightly put, that these kind of joints or crevices we are directly putting in the pavement can be a weak point, because as I had mentioned that water is one of the biggest enemies of pavement.
Hmm.
And if like that electrical can inside that pavement, so that has to be really robust so that it doesn't pop out, otherwise it will interfere with the tire of the aircraft landing, or the water may trickle inside and something. Like I have personally seen that when the repair is going on and the those electrical light cans are taken out, it is full of like a bucket of water, especially in DCA, Gaurav, because like in a lot of places near the river or something, because the water
Yeah.
seeps in.
Yeah.
Hmm.
It will be true in like Mumbai or something airports. I'm not sure, but you can see it in India too.
And then what is the grade of concrete and steel that you use for pavement?
So that is also like project
And
specific, and that can be, yeah. So that is all mentioned in 10H.
oh,
Like we are slowly and slowly. So you know that there are those type 1 cement, type 2, type 3 till
Hmm.
type 5.
mhm.
Yes. Yes.
So America is USA is slowly moving towards type IL cement, which is an eco-friendly version of the traditional conventional cement. So that is one of the biggest changes we are seeing right now in the industry.
Hmm. Anything special in steel that you are using for the runway?
So as I said, we don't have RCC pavement.
Yeah,
We have usually PCC pavement. So I am not aware about
I meant the
as such.
doubles, that they refer to.
So dowels. So yes. So dowels we have. If you guys are aware about the ASTM standards.
Mm-hmm.
So for us, the dowels, this we use plain steel bars for the dowels, and the plain steel bars should conform to ASTM A615. So all the physical and the requirements and otherwise are provided in that A615, and it should conform to that. Sorry, excuse me. Also, they should be free from any kind of deformation, which was restricting slippage in the concrete. So it should not freely move in the concrete, because if it's like moving inside, it should be fixed so that it does its job.
Yeah.
So yeah, it should be epoxy coated. It should be epoxy coated because yeah, it will be like helping in not like in rusting and stuff.
Yeah.
So
Yeah.
Okay, makes sense.
So, if there's no steel, are there any seismic parameters that you have to look out for if you are designing an airport, say in Los Angeles? It is a heavy seismic zone.
so in cities like Los Angeles, like we are required to like study like for to be a PE in California, we are required to give the special exam in California, which involves the surveying exam and the seismic exam.
Yeah.
So as a practicing civil engineer, I'm studying for it right now. So as a practicing civil engineer, if I have to have a PE, I have to clear that exam. As far as design goes, I know that the buildings have like a lot of right now that base, what is it called?
Isolation.
Base
Yeah.
isolation design, and all those things. But as you can see, base isolation you cannot do in a runway. The whole runway will not move with the.
Yeah.
So yeah, that so again think about it. If an earthquake is happening, I mean the runway will just crack. It will
Yeah,
not.
I know.
It will not affect anyone. They will just say
Okay.
ATC will just reroute the planes to the next airport that hey, there's an earthquake, don't come here.
Okay.
So you cannot like do base isolation and those kind of stuff in the runway because it's very easy to tackle it in another way. So, but I do know that yes, we do have to keep the basic consideration in our mind while doing the design there.
So,
So,
But I think but coming to your question, I think the loss of life is dramatically less as compared to like building design. Am I right? Like, does that answer your question?
yeah, it does. I'm just thinking, if what if we use steel in the PCC concrete to at least counter, some of the basic seismic parameters there, a moderate earthquake. I mean, because airports, they are the high importance buildings, and if you have to do medical supplies and do a lot of stuff, so you need runways to land and take off. So I'm just
Yes.
wondering if it's possible, if anybody has done any research,
I have, yes, I have read into it. I also thought about it. So think about it. If a earthquake happens and it is RCC properly like let's take the best case scenario, it is reinforced properly. Well,
yes,
there will be cracks in the
yeah, there
concrete.
will be,
You cannot
yeah.
stop the cracks
Hmm.
unless you cover it in something. If crack happens, that is game over. Because in
Yeah.
building design, I'm studying right now, and I know this from my like BTech knowledge. Even if it's cracked, I mean, it is an indication of a building under duress. It can be in serviceable conditions. I think there are levels,
yeah.
like, right? Correct me if I'm wrong, but even if it's cracked, it can be in serviceable condition. It can be
Yeah.
repaired and stuff.
Yes, yes.
Well, if a spall happens, and if that spall or anything, if it goes into a Boeing or a Airbus 380, it will still cause the damage or possibly serious malfunction or a serious accident.
Yep.
That still doesn't solve the purpose in runway
Hmm.
design. So you have to make sure that in keeping these things in mind, money you have to also keep. Is it
Mm.
really worth it to put
Mm.
those millions of dollars and you're still not achieving anything?
No, understood. Got it. Yeah.
That
So,
was a good.
yeah, one last question of the day, which is the elephant in my mind right now, is then why are the Indian pavements having so much potholes, but why are not the US? Why does the US the pavement doesn't have any potholes?
Water, my friend, water. Simple answer is water. The long answer is improper construction practices. Um it's very, very, very easy on paper. Code is there, engineer knows it, everything is there. Very easy to reject or approve a material. The engineer owners rep construction man, like very easy to reject or approve the construction practices going on. As Anisha was asking about the double bars, and if you are a Gaurav, a construction inspector in USA, you know that if you point out that excuse me, this double bar was not put properly, you will write it if you're FOR, you will submit it in the night. Something will be done by the next
Mm,
morning. Maybe
mm,
even the contractor is fired. What will happen in India? I leave that question to you guys. You guys know the answer better than myself. So yes, it's a big challenge. I will be honest. See, pavement engineering is no rocket science. Okay, like it's very easily understood. It can be very easily. Knowledge transfer is very not easy, but it is not difficult. It's not like we are launching a rocket into the space. So all we need is willpower, like the political willpower you call it, or bureaucratic commitment and whatever to make things properly in India. And once it is there, I'm pretty sure like in India also there are a lot of eligible and efficient and highly qualified individuals who can be who can design these things properly if done with proper construction methods.
And I like what you said, Harsh, actually, because the problem with construction, like if the slopes are not proper and if the materials used are not of high quality, then yes, like repairs are really have to be commonly done. And another
Yes.
question I have is that in India we see a lot of roads which are in concrete, and sometimes to repair them they put like a layer of asphalt on top of it. Uh,
Yes.
like, how do you think a concrete or a PCC road, like a rigid pavement, should be repaired ideally?
So you guys, if you guys have driven, you might have noticed that driving on a good AC surface is better, is a better driving experience than driving on a good concrete surface because
Mhm.
concrete makes noise.
mm,
Like there is this noise going on. So even if concrete is more durable, so that is a very common practice in USA too. We call it APC, asphalt pavement concrete roads. So that is actually done in like it sometimes it's a design requirement, sometimes it's done for like repairs. And coming back to your question, I think it's a money call too. Like again, it's a project specific thing. You have to do your due diligence before giving an answer. But my first guess would be again the repairing with AC is cheaper. Repairing with PCC, driving experience is better on
Okay.
AC. So these two factors I think are the most critical in making this decision.
no, definitely. I mean, in India, it is getting better in some places. We are getting roads like Bandra Worli Sea Link, Yamuna Expressway, the Golden Quadrilateral, the Dream Project, Atal Setu. I mean, these roads, they have better pavements. I hope so. From the images, they look good, and from the people's experience, although we are not like I have personally been on Yamuna Expressway. It's a very
Mhm.
old road, and it's still very well maintained and very well designed. So, I mean, if there is a will, there is a way.
I'm really happy. I'm really happy to know that. I also traveled on the Jaipur. I was going from Madhopur to Jaipur. I don't know the highway name, but it was recently made. I really liked it. Some of the exit lanes were goofy, like
Hmm.
like the geometric aligning. Like it was quick exit, quick entry. Like
Yeah.
you guys have driven in USA, you know what I'm
Yeah.
talking about.
Yeah.
Yeah.
It,
Understood.
you have to make it a little more. The horizontal curves have to be a little more proper to be assisting. So that's, I mean, India has a space crunch, so I
Yeah,
totally get.
that's
So,
highway designs,
Mhm.
that's a highway designer's rule, I
yeah,
would say.
you know, Gaurav. Yeah, I
Yeah,
mean,
yeah,
if
no,
anyone has driven in
understood.
USA, you know what I'm
Mm-hmm.
talking. So
Yes, got it. Yeah. So, Anisha, do you have any questions?
Not, no, I don't have any more.
Harsh, would you like to close the topic today with anything in your mind?
yes, again, I was really nice talking to you guys. Going through this with you. It is very it is very interesting to understand this from a structural point of view, because the questions you guys the type of questions you guys asked, I'm not used to it because my interactions are mostly with the transportation guys. So like Gaurav's question about you were asking about the materials, and Anisha was asking about the double bars. I really liked it. It made me think about it, and I think that yes, India, it is getting, as Gaurav said, yeah, it is getting better in the awareness about the design. It's just about the political willpower now, which we have no control over. So all we can do is just hustle, work, get better, and be ready whenever whenever there is work, whenever the work calls us, project calls us. That's what civil engineers do.
Absolutely. Thank you so much, Harsh, for joining us today. And it was really a pleasure to know more about pavements and runways in particular. So, really thankful to you for taking out the time. And hopefully, we'll have you back on one of the other episodes soon.
Yeah, it was my pleasure to talking to you guys.
Yep. Thank you, Harsh. Thanks for joining.
Thank you very much.
Yep. Thank you guys. Bye.
Bye.
Bye.